So for your warm-up, we had people say what? Square, rectangle, parallelogram, rhombus, what else? Kite, trapezoid. Okay, so those are pretty much it. We are going to do some notes on quadrilaterals. Let me pass this out. Now this is going to require some measurement, so if you got that protractor, you can measure along with me, but I'll be measuring it up on the board as well, so as long as you're following along and filling it in. Alright, so take a look at this. Alright. Okay, so on a square, now we're going to be using the protractor, and again, you can see me using it up here on this little video thing, but you know, measuring each of these angles is what we're supposed to be doing. Obviously, on a square, each angle is what? 90. Okay, so you can see it lining up, 90 degrees. I could do it 4 times, but it would still be 90. So let's fill in 90 for A, B, C, and D. So that's something we know. 90 degrees. Okay, and then we want to measure AB, BC, DC, and AD. And we can do that using the bottom part of the protractor. It's about 2 inches, a little bit more, but we'll just say 2 inches. Why not? Okay, so all the way around it's 2 inches because we already have prior knowledge that a square is regular. All the sides are congruent. So 2 inches, let's put that on here. Okay, and this entire packet, when we're measuring, it's going to be in inches, so there's that. Now, let's fill this in. All sides of a square are what? Now, on our picture here, we know they're all 90 degrees. We can put that here. And we also know all the sides are the same, so we can put those tick marks there as well. And there's another thing we know, is that opposite sides don't cross, which is the word parallel, right? Do y'all know how to show that something's parallel? You know what the symbol is for that? It's a little arrowhead. So if you put like an arrowhead here, an arrowhead here, arrowhead here, arrowhead here, that will be parallel. And then we want to fill in those blanks. So all sides are what? So here's our word box, but all sides are what? Congruent. All right, they're all the same segment, right? So all the same measurement. And all angles are what? Technically, they're all congruent, but specifically, they're all right angles. And opposite sides are, we just showed that with these little arrowheads, they are parallel. Okay? So opposite sides are parallel. So that's your square. By the way, all the properties of all this stuff from this packet are on the very back page. Okay, so like if you want like everything at a glance here, okay, everything about quadrilaterals is on the back here. So, but back to the front, we got down this so far, and we are going to look at the bottom part. So let's go ahead and start, write that down real quick. Start measuring for a parallelogram. Okay, so down here, we have to measure angle J. So I'm going to use my protractor to measure angle J. I'm going to line it up right there. And angle J, since it's obtuse, the bigger number is 120. So J is about 120 degrees. Angle K, if I line it up, measure it, it's about, now it looks like 120, but again, K is acute, so it'll be the smaller number, which is 60 degrees. And when I measure the other ones, angle L is also going to be 120, and angle M is also going to be 60. Okay, so we can write that down on parallelogram. So we had J was 120, K was 60, L is 120, M is 60, okay? Now you can see there's two pairs of congruent angles there. And then we're going to measure JK for realsies. So from J to K, okay, so when you're measuring inches, now this is like something you would have learned long ago, how to measure with 16ths, okay? But this is about 2 3/8. Okay, each of these, the second biggest little lines here. So 2 3/8 is for JK. And then ML actually matches 2 3/8. So let's write that down. And I'm going to be using little fractions. 2 3/8 for JK and for ML. And then measuring LK is about 1 5/8. Sure. Same thing with JM, 1 5/8. Okay. So in a parallelogram, which we had that really fun song. Y'all remember that song? You want to sing it? Why not? All right. So we know that opposite sides are congruent. 1 5/8, 1 5/8. JK and K and ML are the same. They're both 2 3/8. Okay. Opposite angles are congruent. J and L are congruent. M and K are congruent. And then, since it's a parallelogram, the opposite sides are parallel. Okay, so that's a lot of notation. But opposite sides are what? So we just said opposite sides are, what do you think? Okay, they're parallel and congruent. Very good. Opposite sides are parallel and congruent. Opposite angles are what? So what do we notice about these two angles? What do you notice about J and L? They're what? Everybody, stay with me here. I think some of us are listening to music, and that might be preventing us from hearing things, right? What do we know about J and L? Okay, they're congruent, so opposite angles are congruent. And consecutive angles. Now, this is where it's different. What do you notice about J and M? Okay, so this angle and this angle. They're not the same, but what do they add up to? 120 and 60 adds up to what? 180. What do you call it when two angles add up to 180? Supplementary. Okay? Supplementary. Supplementary. All right? So you're definitely going to need to know that when you're doing parallelograms. Two angles that are next to each other are not equal. They add up to 180. Okay? All right. Let's take that and go to the next page. So we talked about squares. We talked about parallelograms. And now we're going to flip it over. Talk about rectangles. Okay? So for rectangles, let's measure this. What do you think we know about all the angles? What are these angles in a rectangle? How many degrees? They are congruent, and how many degrees? 90, right? Each time I line it up, I keep getting 90, so yeah. Let's write that in here. Okay, and then let's measure EF. So EF is about 3.5. HG is also 3.5. And I'm unplugged now. Alright, well now it's got to boot up again. Alright, so 3.5, and then FG is about 1 3/4, 3/8, 1 3/8. Okay. So these opposite sides are equal, and there's two separate opposite pairs that are congruent. Okay, so let's label this 90, 90, 90, 90. EF and HG, those are congruent. EH and FG are congruent. And just like a parallelogram, they are parallel opposite sides. Okay? So a rectangle is pretty similar to a parallelogram, except all the angles have to be exactly 90. So all angles are what? Congruent, but also specifically right angles. And opposite sides are what and what? So what do I notice about these opposite sides? Parallel and congruent. All right, so that's your rectangle. Let's look at the one below that. Now, what's another name for this thing right here? What would you normally call that? Diamond. Now, in math, it's a rhombus, okay? But a diamond shape is called a rhombus, okay? So, just so you know, we want to prefer to use that word rhombus, which is right here. Let's measure these. So, angle N. So, if I line this up to measure angle N, I end up getting 60 degrees. If I measure angle O, I end up getting 120 degrees. 60. And then 120 again. So, kind of like a parallelogram. So, N is 60, O is 120, P is 60, Q is 120. And then I got to measure the sides. Now, I'm going to measure NO, and I get it right about 2.5. OP, about 2.5. QR, 2.5. Sorry, QP, 2.5. NQ, 2.5. Okay, so all the sides ended up being the exact same, 2.5. So what makes a rhombus is that every side is the same. Not only the opposite sides, but every single side. Kind of like a square has all the sides being congruent. The only difference is that the angles are not all congruent. Okay? There are some pairs, though. N and P, those are congruent. O and Q, those are congruent. And then we got parallel sides again. So think of a rhombus like a square that's kind of just leaning over. Okay? The sides are all the same, but the angles have kind of leaned. So all sides of a rhombus are what kind of segments? So what do we notice about all these sides? They're all congruent. Opposite angles. So you can see that with the arcs here. Opposite angles, like N and P. Opposite angles are congruent. And this is where this is important right here. Consecutive angles. Let's look at N and O. N and O are not the same, 60 and 120. But they add up to what? 180, so we call that what? What's that S word? Supplementary. You got to know, angles that are next to each other in a rhombus are not the same, but they do add up to 180 degrees. Cool? Make sure you have that down, and then flip it over. We got 2 more to do. So on the next page, we have a kite. How many of y'all flown a kite? All right. It's been a minute for me. So let's measure this real quick. Okay. Angle R. Now when you're measuring these things, you might have to extend some lines. But measuring angle R is at about 116. Angle U is at about 90 degrees. Angle S is about 90 degrees. And angle T is at about 64 degrees. All right, so it might be kind of hard to see. So R we had 116, T is 64, S and U are 90, okay? So if you look at those angles, do you notice how 2 of them are the same? S and U on a kite are the same. So put an arc on those 2. So part of what makes a kite is that the one pair of opposite angles are congruent. Let's measure RS. RS is about 1.5, and so is RU. It's more 1 3/8, I guess. Yeah, 1 3/8. And then ST is about 2 1/4. Okay, so we end up with 2 pairs of congruent sides. RS and RU ended up being the same. ST and TU ended up being the same. So it's pretty symmetrical down the middle. If you cut that kite down the middle in half, 2 sides are the same, 2 sides are the same, 2 angles are the same. All right? So what are the properties here? A kite has 2 pairs of consecutive sides that are congruent. So RU, RS, those are consecutive congruent sides. UT and TS, those are consecutive congruent sides. And then a kite has 1 pair of opposite angles that are congruent. This is different than a parallelogram, or a rectangle, or a square, or a rhombus. There's only 1 pair, not 2 pairs, but 1 pair that's the same. Can everyone look right here? R and T are not the same. Okay? So I showed that with 2 arcs and 3 arcs. These are not matching. Okay? The only thing that matches is U and S. Okay? Those are congruent angles. Okay, last shape. Talk about trapezoid. Now, what makes a trapezoid is that it has 1 pair of parallel sides. Okay? So let's measure this real quick. Angle W and angle Z, well, those are 90. You can see it, but you can also measure it. Okay, so 90 degrees, 90 degrees. Let's measure X. So that's about 115. Then Y is about 65. All right. So let's write that down. And then WX is about 2 7/8. XY is about 1 3/4. ZY is about 3 5/8. And then 1 1/2. So the measurements are all there. The main thing you got to know, okay, is that these consecutive angles are supplementary. Okay, so these are supplementary. And then these also are supplementary. So a trapezoid has one pair of opposite sides that are parallel. And they make consecutive supplementary angles. Okay, so the bases are parallel, and they make supplementary angles across those bases. Last new thing is at the bottom there, the trapezoid mid-segment theorem. Okay, a mid-segment connects two midpoints. Okay, so look right here. X is a midpoint, Y is a midpoint. So this is a mid-segment. And all you have to do is find half of the sum, or basically average your two bases. So if you had a problem like this, could you add your two bases and divide by 2? That's all you got to do, okay? So 5 plus 9 divided by 2. So 5 plus 9 is 14. Divided by 2. It's literally halfway between 5 and 9. You get 7, okay? So that's a basic version of the mid-segment that we're going to get more practice on as it comes. But now you have this notes packet. Again, the very last page looks like this. Has all the properties that you need, okay, for everything. So with that information, I'm going to get you the assignment that you can get a head start on today, which we're going to definitely work on tomorrow as well. So let me give you a hint on number 1, okay? Number 1 says it's a parallelogram. So here's my parallelogram notes, right? On number 1, I'm trying to find A, B, C, D, and E, right? Now, what do I know about opposite angles? They're the same. So if you know one angle on number 1, you know the opposite angle across is going to be the exact same. And then we also know that consecutive angles right next to each other are supplementary. So the two angles that are next to each other have to add up to 180. That's another thing you know. And don't we also know the opposite sides are the same? So like if 22 is one side length, the opposite side is also going to be 22, right? So you should be able to get E pretty easily, and letter D pretty easily, and letter B pretty easily, okay? So I think you can definitely get started on number 1, okay? Let's give it a shot.